In 1900, American farms looked much the same as they had for centuries. Horses pulled plows, wagons hauled crops. Steam engines, massive and dangerous, handled the heaviest work. A farmer working a quarter section needed horses, hired hands, and considerable luck. By 1950, that world had vanished. Children watched their fathers abandon technologies their grandfathers had considered modern. 5 innovations drove this revolution, each one building on the last, each one pushing agriculture toward a future that would have seemed impossible to farmers of 1900. These weren't incremental improvements. These were the machines that changed everything. Before there was a truck on every farm, there was the wagon. 4 wheels, a wooden bed, horses in front. This arrangement had worked for centuries. In 1907, International Harvester saw something different. The company that had already brought mechanization to the harvest understood that power could transform transportation too. In February, production began on the auto wagon at IH's McCormick Works in Chicago. This wasn't a converted automobile, it was purpose-built for farm work. A 2-cylinder, air-cooled engine produced around 15 to 20 horsepower. High wheels gave the clearance needed for rutted rural roads. The instruction manual warned against speeds over 20 miles per hour. In its first year, International Harvester built just 73 auto wagons, roughly 7% of all motor trucks produced in America that year. But production jumped tenfold in 1908 to 725 units. By 1909, nearly 2,500 machines rolled off the line annually. The genius lay in versatility. The rear seat could be removed, transforming a passenger vehicle into a cargo hauler. International Harvester advertised that the auto wagon could do the work of 2 horse-drawn rigs while eliminating the costs of feeding extra animals. One owner in 1923 reported still using his auto wagon after more than 20,000 miles, testimony to the durability working farmers demanded. Today, no self-respecting farmer operates without a pickup. That tradition began in 1907. Steam tractors required enormous quantities of water and fuel. A trained engineer had to run them. On dry prairies, one spark could set an entire field ablaze. John Froelich understood these problems. Born in 1849 in Iowa, he ran a mobile threshing business with steam equipment. He'd watched farms burn. He knew there had to be a better way. In 1892, working with his blacksmith Will Mann, Froelich found it. He mounted a single-cylinder Van Dusen gasoline engine onto a steam engine frame. The result was the first successful gasoline-powered tractor that could drive both forward and backward. That September in South Dakota, the machine powered a thresher that processed 72,000 bushels of grain. No water problems, no fire danger. It worked. The commercial reality proved harder. A company formed to manufacture tractors built only 4, sold 2, and had both returned. But the seed was planted. By 1918, John Deere purchased the successor company for $2,350,000. That facility in Waterloo, Iowa, continues producing tractors today. Meanwhile, Charles Hart and Charles Parr built what historians recognize as the first commercially successful gasoline tractor. The two had met as mechanical engineering students at the University of Wisconsin in 1892. After graduation, they built stationary engines in Madison before relocating to Charles City, Iowa in 1901 to focus exclusively on tractors. Their Hart Parr No. 1, assembled during winter 1901 to 1902, was sold to a farmer in nearby Clear Lake. It was still running 17 years later. Hart Parr never had a tractor returned. In 1907, their sales manager coined a new word to replace gasoline traction engine. He called it a tractor. By the early 1920s, gasoline tractors had proven themselves for heavy work. But row crop cultivation remained the domain of horses. Planting and cultivating corn required precision that early tractors couldn't provide. The breakthrough came from Bert Benjamin, an Iowa-born engineer at International Harvester. His concept, an all-purpose tractor that could handle row crop work while still managing drawbar and belt duties. They called it the Farmall. The machine featured a tricycle configuration with closely spaced front wheels that ran between planted rows. Large rear wheels provided 30 inches of clearance to straddle young crops. Cultivators mounted in front so operators could watch their work. A power takeoff drove various implements. IH management worried the strange-looking design might not sell. Early farmers thought it looked funny. When the first 200 tractors shipped in February 1924, they went primarily to Texas, limiting potential embarrassment if it flopped. It didn't flop. At $825, the machine could replace horses for virtually every task. By 1926, demand forced IH to purchase a plant in Rock Island, Illinois, specifically for farmall production. They named it Farmall Works. By 1930, the company was building 200 farmalls per day. Every major manufacturer scrambled to copy the design. John Deere introduced its GP tricycle in 1928. Oliver Hart Parr followed in 1930. By 1940, approximately 90% of all tractors sold in the United States were either farmalls or machines using the Farmall design. The Farmall H became the top-selling individual tractor model in North American history, with over 390,000 units sold. Steel wheels came with serious costs. Vibration shook bolts loose and wore out machinery and operators. Many localities passed laws prohibiting tractors on public roads because steel wheels destroyed pavement. Approximately 1 million tractors worked American farms in 1932, everyone on steel wheels. Harvey Firestone saw opportunity. The founder of Firestone Tire and Rubber had grown up on an Ohio farm. He understood that farmers would pay for solutions that saved time and fuel. In 1932, Alice Chalmers engineers worked with Firestone to test low-pressure aircraft tires on a Model U tractor belonging to Wisconsin farmer Albert Schroeder. After 1 week, Schroeder was convinced. The ride was smoother. Fuel economy improved dramatically. In October 1932, Alice Chalmers became the first manufacturer to offer pneumatic rubber tires as standard equipment. But farmers remained skeptical during the Depression. Alice Chalmers and Firestone responded with audacious marketing. During summer 1933, they sponsored tractor races at state fairs across the Midwest, featuring Barney Oldfield, the most famous race car driver of his era, the first man to drive an automobile faster than 60 miles per hour. Now, Oldfield was going to drive a tractor even faster. The racing tractors were stock Model U machines with high-speed gears. On September 17, 1933, Oldfield set a world tractor speed record of 64.28 miles per hour. Racing legend Ab Jenkins later pushed that record to 67.87 miles per hour on the Bonneville Salt Flats. More than 1 million spectators reportedly watched during the fair circuit. But the most convincing argument came from Nebraska's official tractor testing in 1934. Using the same tractor, engineers recorded 5.62 horsepower-hours per gallon on steel wheels. On rubber tires, 8.18, a 45% improvement. By 1937, 43% of new tractors were ordered on rubber. By 1940, it hit 95%. Before Harry Ferguson, implements connected to tractors the same way they had connected to horses, by chains or a drawbar. Depth control required constant lever manipulation. When a plow hit a buried rock, the sudden stop could flip the tractor backward with lethal results. Ferguson was an Irish farmer's son with a mechanical mind. He watched operators struggle, he saw accidents, and he began experimenting. His first insight: implements should connect rigidly to the tractor so both function as one unit. This would prevent backward flipping because the implement's weight would stabilize rather than overturn the tractor. In 1926, Ferguson patented his three-point linkage in Britain. 2 lower arms and 1 upper arm attached implements so the lines of draft converge near the tractor's front axle. The combined unit became highly maneuverable. Ferguson's second invention was draft control, a system that senses the force required to pull the implement and automatically raises or lowers it to maintain consistent depth. The implement adjusts itself. By 1933, Ferguson had built his prototype in Belfast. The black tractor, painted in gloss black with an 18-horsepower Hercules engine. It proved his system worked and today sits in London's Science Museum. He partnered with David Brown Lantetted in 1936 to produce the Ferguson Model A, the first production tractor with a hydraulic three-point hitch. But only 1,356 were built before disagreements ended the partnership. After demonstrations on Henry Ford's estate in 1938, the legendary automaker entered into a handshake agreement that put Ferguson's system into mass production. The result was the Ford 9N in 1939. At just 2,500 pounds, this light tractor could outplow heavier, more expensive machines because the three-point hitch transferred implement weight to the drive wheels, dramatically improving traction. The partnership ended acrimoniously after Henry Ford's death, but Ferguson's system had already won. Today, virtually every tractor sold anywhere in the world features a three-point hitch based on Ferguson's design. Now that his patents have expired, every manufacturer incorporates this technology. It may be the most revolutionary improvement in tractor technology during the 20th century, the invention of one determined Irish farm boy. These innovations didn't arrive in isolation, each built on possibilities created by those before. The gasoline tractor needed transport, enter the farm truck. The general-purpose tractor needed mobility, enter rubber tires. Every tractor needed efficient implement control, enter the three-point hitch. Together they transformed American agriculture from an industry that looked backward to one that constantly pushed forward. In 1900, a farmer with horses might work 40 acres and count himself fortunate. By 1950, his son on a rubber-tired farm awl with hydraulic implements could handle a quarter section alone. This wasn't just mechanical progress, it was a revolution in what farming could be and what farmers could achieve.